in this video, we're going to do a demo showing you how to do model training with the Databricks API. But before we start, we want to really spend some time showing you where you can find all the amazing Databricks demos that we have open for anyone to use. So you really need to go to
dbdemos.ai.
dbdemos.ai. And you're going to find this page where we have all the different tutorials for each kind of segment. So about the whole platform, engineering, data science. And we're going to do a demo from here about fine-tuning. So you click here, let's say, and then you can download all your notebooks or you can pip install it. And you have it in your Databricks environment. And then you can go with it. The data are open, so you don't need to have any specific access to the data. Mm-hmm. So we're going to do a demo on the Model Training API. And we are here. So we have done exactly this process. We download the demo from dbdemos.ai. And what we're trying to do here is take some data from the Databricks documentation and fine-tune a model or be able to understand or be more specific on how to answer these questions based on the tuned model we have now. So we're
going to tune the model with the Databricks documentation so that we can ask it questions about Databricks and it answers.
Exactly.
Okay.
So it's mainly a chatbot, right? And the first thing you need to understand about fine-tuning is that the data is the main key challenge that we have to solve. Because the data needs to be in exactly the same format as the format the model will expect to take it to answer, right? And given that, in our case, it's a chatbot on the Databricks documentation, we have to provide the data into a chat format. Also, another thing here is that our final application will work with a fine-tuned model, but also with a RAG layer. So we keep our RAG layer, we take our model, the LLM model, we tune it, we'll fine-tune it on this documentation, and then we will switch the old model with this fine-tuned model. Okay, so in a RAG situation, what we have usually is we get our questions, we find the relevant context from the vector store, and then we get the answer back. So in order for the fine-tuned model to work in this case and understand the data with this context, we have to provide it with the question and the context, right? And the human answer is there to baseline it against how good or bad was the actual answer the model created.
Okay, so this is a baseline of what good looks like.
Yes,
so that
we will compare it to allow the model to learn.
Makes sense.
So this is the architecture. So we're going to take the questions and the context and then try to fine-tune the model and calculate error based on the actual human answer. And then we are going to use the MosaicML Model Training API to fine-tune the model and log it with Unity Catalog. So let's see how this looks like. Okay, so you have the question asked to the model, you have the answer that was provided to the end user, and you also have the content. And this, think of it, that came from your vector search. Okay, so that is the relevant content that came from your vector search.
That's what was retrieved from the vector search.
And this is how your data set look like. Now, in order to prepare it, we have to bring it to the right format. And because we are using a chat model, we are going to use the chat completion format. Okay, and how does this look like? It looks like this. We have the role, which is the system prompt in this case. Then we have the user and what was given by the user, answer this question, for example, and then what is the actual answer. And this is the format we are passing all our data in. Now, let's go into the code and how this looks like. Let's see how we can prepare the data to bring it to the format that we require for our model. Again, remember here that each model may require the data in a little bit different format, so just check this beforehand. And also, as we said in a different video, the Model Training API works with specific models as of now. We support specific models for fine-tuning, so just keep an eye on the documentation.
Yeah, look at the documentation to see what's available. It changes all the time as well. So.
So let's come back here to the demo. So we have our system prompt, which explains mainly what this assistant is going to do, right? And in our case, it's our Databricks support assistant, and we declare what this assistant should or should not do. And then mainly, this function brings the data into the format, the chat completion format we require.
Yeah, it's a pre-processing step, right?
Exactly. Given that we're using Mistral here, we need to bring it into this specific dictionary format, and we iterate for all our data, and we're passing mainly the system prompt, the user input, and the content, and the actual question, the actual answer, sorry. So here, this is how the data look like after this process. We have for the role of the user and the content, we are saying this is the system prompt, as you can see here. And then after a point, if your question is as clear, blah, 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 after a point here, it actually provides all the content retrieved from the vector store.
Yeah.
And then here is the answer. So you are answering with this. You can use the stack. So this is the correct answer for this specific question. So this is our data. And let's see how we can do the fine-tuning run.
And so what you were saying is that we should not underestimate how long it might take to do this pre-processing step, and that it's a really key.
Yeah, so the data is the key step. If you bring the data to the wrong format, this is not going to work. If the data is not clean, this is not going to work. So be careful what data you are passing and make sure you have validated that they are correct and accurate, right? So back to the quality problem, like if whatever your data is not good, whatever you're going to get out of the training process, it's not going to be good.
How much data does it need?
The fine-tuning, depending the fine-tuning you are doing, but the instruction fine-tuning can work with a couple of thousand of rows, right? So
really?
Even you can try it with 500 rows, to be honest, if you have good quality examples.
Yeah, then the higher the quality, the better. But you can actually get started with just 500 rows.
That's 500. Really... A couple of thousand will be great, but you could even try with 500.
Amazing.
So let's see how we can kick off the training run. Now, the training run or the fine-tuning run, you can do it through the API as we're going to show you here, but also through the UI, which we're also going to show you. So it is very simple because it's 100% abstracted from you, right? So you just import the right libraries. You make sure you have the right cluster and all the requirements for the cluster, and then you kick off this run, which is this. What it requires is where to go and mainly what is the cluster in which we are going to access the data from, and we're going to run the process. Then we need the base model, which is the model we are fine-tuning. In our case, it's Mistral. Where is the data sitting? Okay. What is the task type we are trying to tune for, right? So is it the supervised, unsupervised, chat completion? In our case, it's chat completion. What is the model, how to register it in Unity Catalog? How much training epochs to run? In our case, it's very small just for the sake of the demo here. And what is the learning rate? So how fast we should go through the training process.
So it's a very, it's really
simple, abstractive.
Simple. Yeah.
The only thing you have in control here
is the preprocessing.
Right? So make sure you do your preprocessing you spend some time doing it correctly. And if you have that done, then it's going to go train the model. It's going to take some time depending what model you chose and how much data you are passing. And then what you can do is you can log it in an MLflow experiment and go and see all the different metrics for the training run as we're going to show you here. So if you open the model that we're fine-tuning.
Yeah, on MLflow, there's so many great features that came out. So we also did a dedicated video on all the latest announcements with our colleague Puneet.
Yes.
So make sure to check that out as well.
Exactly.
So we spent 15 minutes diving into those features.
So here you can see how, your loss is going down, which is good given this, given we are trying to tune the model, how the perplexity is going down, how the token accuracy is going down over the different steps. And so this is really integrated with MLflow. And you can, when you do MLflow.run, it goes and actually tracks all of these metrics for you, which is beautiful. And then, as you can imagine, since the model exists in Unity Catalog, you can go serve it as an API as usual. Nothing really changes here, so I'm not going to spend time on this. But I will spend some time actually showing you how you can do it also through the UI, which is very simple. So if we go here to the experiment page, You can come here to the foundational model training.
Well, they're going to change the name. They're going to change the name.
I was confused for a bit. Yeah. And then you click here and you have again your 3 tasks. Mainly, you choose which task you want. You choose the model you care to tune. You pass the training data where your training data set is, where to register the model in which catalog, give it a model name. You have also some advanced options as we had in the API, like how many epochs to train for, the learning rate.
Sorry, one second. On the training data,
the feature, the preprocessing step needs to be done beforehand.
It needs to be done beforehand, makes sense.
And you just link your final table here.
Good.
And here the context length is interesting. This matches with the context length of the models we're trying to fine tune, right? So if you push, so you need to make sure your data set is prepped for this specific context length. If you pass more, it's going to be cropped. So just make sure you choose the model, you understand what is the context length in terms of tokens, right?
Yeah.
And then you need to do your preprocessing step in the same way. Here you can also pass some evaluation data set to test your model on, and some specific prompts.
So evaluation data, we mean ground truth?
Yes.
In this case?
Yeah, so what is some data that were correct, and we want to make sure that the model answers in very similar way to this evaluation data. And also prompts, like what questions should we ask the model to evaluate it on this data set. Good. And you can add a couple of here. And you can even keep fine-tuning from a different fine-tune model or a specific checkpoint that you have already somewhere stored. So you can link it here and continue the fine-tuning process. And that's it. And then you click Start Training, and it's going to kick off the run and log all the experiments in MLflow as...
What's the advantage of training from a specific checkpoint?
You may have done already a fine-tuning process and you got some new data that you want to keep fine-tuning on, for example, right?
Oh, yeah.
So you want to keep fine-tuning a process.
Yeah.
Other than that, we're good.
Yeah, that's amazing. That's actually...
It's very abstracted. So a lot of things happen behind the scenes that we don't see and makes it much easier.
Amazing.